This question wants us to find the Norton equivalent circuit for the circuit in figure below at terminal AB. This question wants us to redraw this circuit into the Norton equivalent circuit, which consists of I Norton, which is parallel with the R Norton. There are 3 steps for us to find the R Norton. The first step is to replace the chosen load with break, which makes this an open circuit, and the next step is to replace the voltage source into wire, which makes this a closed circuit, and the third step is to replace the current source into break, which makes this an open circuit. When we apply the 3 steps into these circuits here, we can redraw it to be this circuit. As you can see, there are no chosen load for this question. However, we replace the voltage source with wire and the current source with break. This circuit can still be simplified because the 8 ohm and 4 ohm and 8 ohm is in series. This is equal to this. We are able to calculate the Rn from this simplified circuit, where the Rn is the resistance from one load terminal to the other. In this circuit, the 20 ohm is parallel with the 5 ohm, and we get that the Rn is equal to 4 ohm.
Okay, so the next step is to find I Norton. To redraw the new circuit for I Norton, we need to ignore this 5 ohm resistor because the terminal AB is already short circuited. So the new circuit will become like this. So the I Norton will go through this wire. Okay, next, to find I Norton, we can use any method such as mesh analysis. So if we use mesh analysis, we can create the 2 loop of current here. This is I1, this is I2. So this is loop 1, this is loop 2. Then we can create the equation. For loop 1, since we know the source of current is 2A, so eventually the I1 will become 2A. For loop 2, we can create the equation by using V equals to IR formula, which is Kirchhoff law formula. So it will become I2 times total resistance for loop 2, which is 4 plus 8 plus 8 minus 4 I1, since I1 direction is opposite of I2, equals to 12, which is this one. Okay, so 20 I2 minus 4 I1 equals to 12. So we know the value of I1, we just substitute. So we get I2 equals to 1A. From the circuit, we know that I2 equals to IN, so I Norton equals to 1 ampere. So for the final circuit, after we calculate the I Norton and R Norton, our final circuit will be looking like this. This is I Norton, this is R Norton. I Norton will be parallel to R Norton. So that's all from us. Thank you.